In this video, we have to learn about dimension and its applications. Dimension and its application. First of all, what is dimension? Dimension of a physical quantity are those power which are raised on fundamental units to express its unit. The expression which show how and which of the base quantity represent the dimension of physical quantity is called dimension formula. In general, if we talk about dimension, dimension is that formula in which we represent number of formulas in general form or general terms of mass, general terms or in general dimensional terms of mass, length, time and current. As in physics, we have number of formula when we express that different formulas in general terms of mass, length, time and current dimensions that give us the dimension formulas. For mass, dimension is represented by capital N with a square bracket. Dimensions are always write in the form of capital letters and with a square bracket. For length, dimension is capital L with the square bracket. For time, dimension is capital T with the square bracket. For current, dimension is A with the square bracket. So, let me show an example for dimension. For example, we have to write dimensional formula for velocity. As we know, velocity is equals to distance by time. Velocity is equals to distance by time, where dimension of distance is actually length and dimension of time is t. So both having power 1 each. When we take or when we bring t raised to power 1 from denominator to numerator, its power changes to -1. So we get L1 t minus 1. So this is the dimension of velocity, or we can also write it as m0 L1 t minus 1. This is also dimension of velocity. Let us take another example. For charge, formula of a charge is current into time. Current into time, where dimension of current is A and dimension of time is T. So we get dimension of M0 L0 T1 A1. We always try to write first M, then L, then T, then A with whatever power. If M and L is not present, then we write them with M0 and L0, because something raised to power 0 is always 1. Something raised to power 0 is always 1. So there is no actual effect of writing this value with power 0 in this formula. So there is a chart. This is a chart of different formulas. This is a chart of different formulas in terms of dimension. So you must go through once it. Now next is homogeneity principle. If dimension of left and right hand sides are equal, then dimension of equation is then formula is dimensionally correct. If left hand side and right hand side dimensions are equal, then formula is dimensionally correct. This is known as homogeneity principle. Means if left hand side dimensions are equals to right hand side dimension. Next is applications of dimension. First application, to check the accuracy of physical equation. Second, to change physical quantity from one system to another. And third, to obtain a relation between different physical quantities. First, to check the accuracy. checking the accuracy or correctness of a formula. This is the first point. So according to this principle, only that formula is correct in which dimension of various term on one side is equals to dimension of the term on other side. If dimension of left hand side term and right hand side terms are equal, only then, if left hand side dimension is equals to right hand side, only that given formula is correct, otherwise it is not correct. For example, suppose we have a formula v is equals to v square equals to u square plus 2as. This is equation of motion. I think so you already had learned about this equation in class 9. So on left hand side we have velocity. This is velocity. V is final velocity, u is initial velocity, and a is acceleration, s is distance or displacement. So on left hand side we have velocity square. So dimension of velocity that we already know, that is L t minus 1 its whole square. So it is L square t minus 2. This is dimension on left hand side. Now comes to dimension on right hand side. V square u square plus 2as. Left hand side we have dimension L square t minus 2. Now comes to right hand side, u square, that is again L square t minus 2 plus 2 acceleration. The formula of acceleration is velocity by time. Dimension of velocity is L t minus 1 upon t. If we take this t again in upside, this become L t minus 2, and dimension of s is L. S is what? Displacement or distance, its dimension is L. So it is L into L square. L square t minus 2 plus 2 L square t minus 2. This constant do not count. We do not count this constant because we are just checking the dimension equality on both sides. So this is same and same. This both get added up, or if we get L 3 times, if we add this simply we get 3 times this, or if we just ignore this, this is L square t minus 2. So this dimension is same on both sides. We not to have anything with the constant value, we just need to check the dimensions. As dimension is same on both sides, so this is a dimensionally equal formula. Suppose we have a formula of s is equals to u plus 8t square by 2. This is the formula. Now on left hand side we have dimension L only because distance. Now on right hand side u means Lt minus 1 plus, neglecting this 2 because we have nothing to do with the constant, we just have to check the dimensionality. Now for a it is L t minus 2, and this t square, this is capital T square, t minus 2 t plus 2, that is t0, L t plus 2 minus 2, simply 0 plus L t minus 1. So we get here L t minus 1 plus only L, because something raised to power 0 will be 1. So this both dimension are not equal, so we don't add this with this, so both not get add. So left hand side dimension is not equals to right hand side dimension, so this is dimensionally wrong formula because there is t is missing over here. We know that actual formula is s is equals to ut plus half at square. So it's also dimension also helps to check correctness of a formula. Second application is to convert one system of unit into another system of unit. To convert one system of unit into another system of unit. The example of this is the next conversion of one system of unit into another. For this we know that in one system we have a number and its unit, n1 u1, and in second unit system we have its number and unit. This is number, this is unit, number, unit. Now This is actually formula for conversion of one system of unit into another. Suppose in one system u1 is this, in second system u2 is this. We have to find, we know the value of n1. We know the value of n1, we have to calculate n2. We have to calculate n2. n1 u1 equals to n2 u2. We know the value of u1, u2 and n1. We have to calculate n2. So n2 is what? n1 u1 by u2. The value of u1 is m1a l1b t1c. Value of u2 is m2a l2b t2c. We just substitute the value here. This is n2 equals to n1. Value of u1 is m1a l1b t1c upon m2a l2b t2c, or we can also write it as m1 upon m2 raised to power a, l1 upon l2 raised to power b, t1 upon t2 raised to power 3 c into n1, that is equals to n2. Now once we get the value of n2, we have converted one system into unit to another. For example, we have to convert 1 joule into arc. Or say, take very simple example. We have to convert 1 meter per second square into centimeter per second square. We don't know the value here. This is n1 now. Comparing this equation with n1, u1, n2, u2. n1 is 1. n1 is 1. u1 is equals to meter per second square. n2 we don't know. And u2 is centimeter per second square. So to find n2, we do what? n1 u1 by u2. n1 is 1. u1 is meter per second square. u2 is centimeter per second square. Per second square get cancelled. Where 1 meter equals to 100 centimeter upon centimeter. Centimeter get cancelled with centimeter. We get n2 equals to 100. So 1 meter per second square equals to 100 centimeter per second square, or 1 meter per second square equals to 10 raised to power 2. We can also write 2 zeros are 10 raised to power 2 centimeter per second square. So this is conversion of one system to another. Third is to obtain a relation between different physical quantity. How we can do that? This is a question to convert 1 Newton in Dalton. You can do this because 1 Newton is kg meter per second square. This is Dalton is gram centimeter per second square. So you have to convert this by yourself. Now third application is to drive a formula. Now to drive a formula, let's do an example here. Suppose we have to drive expression of time period which may depends upon mass, length and acceleration due to gravity. So we know T depends upon mass, length and acceleration. So we simply write T is directly proportional to m raised to power a, l raised to power b, g raised to power c. Now writing the dimension on both sides, T dimension is capital T raised to power 1 equals to some k constant, mass raised to power a, dimension of l is capital and dimension of g. G is actually acceleration due to gravity. Its dimension is equals to acceleration, that is lt minus 2. So we get lt minus 2 with power c. So by solving we get ma l raised to power b plus c and t raised to power minus 2c equals to with k. This here m0 l0 t1. Now ignoring this constant because we have nothing to do right now with constant, we just have to drive the relation. So comparing power of m, l and t on both sides. Here power of m is a, here power of m is 0. So A is equals to 0. L raised to power 0, L raised to power B plus C. B plus C is equals to 0. T raised to power 1, T raised to power minus 2C. So here we get A 0, B plus C 0, C minus 1 by 2. Substituting the value of C here, we get B equals to 1 by 2. So T is equals to K M raised to power 0, L raised to power B, B is 1 by 2, and G raised to power C, that is minus 1 by 2. So this is T equals to K time M raised to power 0 is 1, something raised to power 0 is 1, L raised to power 1 by 2. Here G raised to power minus 1 by taking G in denominator, its power will get positive. So we can write K L by G raised to power 1 by 2. 1 by 2 represent under root 2. So it is equals to T equals to K time under root of L by G. So this is the formula of time period of pendulum, that is T is equals to under root L by G, where this constant is equals to 2 pi. So formula is time period equals to 2 pi under root L by G. Now there are some limitations too. With application there are limitations. First, this gives no information about dimensional constant. Dimensionless constant like K, 1, 2, 3, it do not give any, like in previous formula we do not get any value of K. The value of K, if we know, then we substitute, but otherwise if I not know the value of K, then the formula is just T equals to K under root L by G. So it do not give any information about dimensionless constant. Second is, if the quantity depends upon more than 3 factor having dimensions, the formula cannot be derived because it will get difficult. We cannot derive formula containing trigonometric function, exponential, log. Means in a if in a question or in a formula function is of sine theta, cos theta, e raised to power and log, then we cannot find it. Method of dimension cannot be used to derive exact relation when it consists of more than one part on any side. Means like this, if we have to find this formula, we cannot derive. We can check the dimensionality, but we cannot find this exact formula. It gives no information whether physical quantity is a scalar or vector quantity, because from here we do not get about any sign, so we don't come to know about anything about that it is a scalar or a physical quantity.